The factoring pattern we're going to look at today is factoring perfect square trinomials. And as we get into it, you'll find that it is really very closely related to factoring x squared plus bx plus c, where c is positive. But as we did before, let's talk about this, connecting it to arithmetic. If I give you this expression, you know to read that 5 squared. That's the exponential form. It means 5 times 5, which is 25. Because we got 25 by squaring 5, we think of 25 as a perfect square. As always, what we do with algebra is an extension of what we do with arithmetic, only involving variables. So instead, let's call this x plus 5 squared. So we know, just like when we squared 5, if we're squaring something, we're multiplying it by itself. And now that you're experts at foiling, you can see that this is x squared plus 10x plus 25. And it is just like 5 squared. This is a perfect square. It's a perfect square trinomial. Because we got it by squaring x plus 5. Now, I just want to take a minute to say, please notice that x plus 5 squared does not equal x squared plus 25. This, in my experience, is the most common mistake in algebra. Anytime you have terms that are added or subtracted, anytime you square terms that are added or subtracted, you need to expand them by foiling, and that will give you this middle term from the O and the I of FOIL. So let's be clear about that. A little bit more complicated. Let's say 2x plus 5 squared. Well, we know now that since there's a plus here, in order to expand it, I cannot call it 4x squared plus 25. No! Instead, I need to expand it. 2x plus 5 times 2x plus 5. When I FOIL this, first gives me 4x squared, outer gives me 10x, and inner is also 10x. So together they are 20x. And last is 25. So 4x squared plus 20x plus 25 is a perfect square trinomial because it is the product when you square 2x plus 5. Let's line up the two different perfect square trinomials that we've seen. The first one was x squared plus 10x plus, x squared plus 10x plus 25. That's what we got when we said x plus 5 squared. And I want you to think about the fact that if I am squaring this, the expanded form is 2x plus 5 times 2x plus 5. That means the 2x, if I'm squaring it, these are the same, and these are the same, which means that 4x squared has to be, the first term of a perfect square trinomial has to be a perfect square, because that's what you get when you multiply the first terms. The last term also has to be a perfect square, because it's what we get when we multiply the lasts. Same thing here. X squared has to be a perfect square, and 25 has to be a perfect square. And by the way, it has to be positive, because even if I'm multiplying, let's say if I were to do, okay, let's do another one right now. Let's say 2x minus 3 squared. It means I'm multiplying 2x minus 3 times 2x minus 3. Because I'm squaring it, they're exactly the same, the two binomials, which means their first numbers, first terms, when you multiply them, they're going to give you a perfect square. And your lasts will always give you a perfect square as well, because 3 times 3 is 9. And if they're a negative times a negative, it's going to be positive. So this sign is always going to be positive. The middle is going to be what you get when you combine the O and the I of FOIL. Negative 6x plus negative 6x is negative 12x. So you'll see, once again, this term is a perfect square, and this term is a perfect square. So when I'm factoring a perfect square trinomial, the first thing I want to do is, actually, if I have to decide if something is a perfect square trinomial, the first thing I want to do is look at the first term and the last term and say to myself, are they perfect squares? Okay, so I have to answer that question for myself. Let's take a completely different one. Let's say y squared plus 10xy plus 25y squared. So where we left off is we're going to look and see, is this a perfect square? And is this a perfect square? And by the way, in this, these terms that have 1 as an exponent need to be in the middle. Okay, so yes, they're perfect squares. If the answer is yes to are they perfect squares, what you want to do is try factoring them. We're going to put in our variables. We're going to take the square root of y squared to go here. We're going to, oops, sorry, this should have been an x. We're going to take the square root of x squared, and that's x and x. This sign tells me they're the same. This tells me what they both are. And now I'm going to look for the square root of 25y squared, which is 5y. Once I do that, now I just need to check the O and the I and find out, do they add up to 10xy? And yes, they do. So this is a perfect square trinomial, and this is how you factor it. Notice, this is exactly a ax squared plus bx plus c, where c is positive, because my coefficient is 1. It's a little bit harder when the coefficient isn't 1. Let's take a look at the idea of, let's see, where's a good one? 25x squared plus, nope, sorry, it's a minus, minus 15xy plus 36y squared. So, if you remember, the first thing when I look at a problem like this, and I'm trying to see if it's a perfect square trinomial, I ask myself, are the first and last terms perfect squares? If the answer is yes, then you want to create a guess based on the square roots of each of those. So I'm going to draw my parentheses. This sign tells me they're the same. This tells me what they both are. That means they're both going to be negative. My guess is going to be the square root of this, which is 25x squared. The square root of 25x squared is 5x, because the square root of 25 is 5, and the square root of x squared is x. So I'm going to put the square root of the first term in the place of f, the first terms of the binomials. Now I do want to do the same thing, and I want to say, what is the square root of 36y squared? It is 6y, because the square root of 36 is 6, and the square root of y squared is y. Now I need to check and see if the O and the I add up to the middle. This is negative 30xy, and this is negative 30xy, which does not add up to 15, negative 15, so it's not a perfect square. So when you're doing the problems for the homework, what you want to do, the directions say, the factoring part says, first, decide whether each trinomial is a perfect square, and second, if it is, factor it. If it's not, write not a perfect square. So if we look at one of the problems, we say p squared minus 14p plus 49. What I want you to do to find out if it's a perfect square trinomial, you want to say, is this a perfect square and this a perfect square? The answer to that is yes. So now I want you to make your guess. Oops, not Gus, your guess. G-U-E-S-S, based on the square root of this number, this term, which is p and p, the square root of this term, the last term, which is 7 and 7. We know that the signs are the same and they're both negative, and now you have to check the O and the I. Negative 7p and negative 7p does equal 14, so yes, this is a perfect square trinomial, and this is how you factor it. I want to look at one where the variable is in the last place and see what we can learn about that. Let's say, let's see, 144 plus 12y plus y squared. The middle term is still the linear term, or having an exponent of 1, so this is okay. Sometimes they reverse these, and it still means we're still looking for whether this and this, the first and last terms, are perfect squares. So we're going to draw our parentheses. We're going to use the square root of the first term in each of the first places, the square root of the last term in each of the last places. We're going to put in our signs. They're both plus, because this sign tells us they're the same, and this tells us what they both are. Now we're going to guess the O and the I. 12y plus 12y is 24y, not 12y, so it's not a perfect square. But as you also saw, when the variables come at the end of the trinomial, they also have to go at the end of the two binomial factors. I think that that's really all you need to know about this. Just remember, though, that when the coefficient is 1, it is exactly with the, like, x squared plus bx plus c with c positive. It's only confusing when there's also a coefficient. Let's just do one last problem. 25x squared minus 15xy plus 36y squared. In determining if this is a perfect square trinomial, is this a perfect square and is this a perfect square? The answer is yes, because 25 and 36 are both perfect squares, and these are both even exponents. So I'm now going to make a guess based on the square roots of each of these, the first and the last terms. The square root of 25x squared is 5x. The square root of 36y squared is 6y. Because this sign is negative, that means I need to put negatives in each place. Now I check the O and the I. They give me negative 30xy, which is not 15, so it is not a perfect square. Okay, so in review, what you want to do is ask yourself, are the first and third terms perfect squares? If yes, make a guess using their square roots. That would be step 2. Step 3 is check the O and the I of FOIL to find out if it works.